Hey there, welcome back to the channel. So in the previous video, we made some mistake. Well, I made some mistake, and what was the reason? Because I was sleepy. As you can see, the previous video it's just 30 minutes long because I was like really sleepy and I was recording it at 12. What do we call 12 a.m. Yeah, 12 a.m. At night. So, yep, we are going to correct that. And what was the mistake? So let's say this is my reallocate function. So I want to reallocate the block. I've covered the condition where our reallocation is actually a smaller one. So our block, which was already allocated, we have to shrink it. So this is already covered. So no problem more. So, but over here, we have to check the condition where the reallocation is we have to allocate a bigger block. So what can we do in that case? We cannot just call malloc every time. So a better way to go forward is that whenever we want to increase the size of the block, we can check its adjacent blocks. Is it left like the left block is the left block free? So this is what the function is. This checks if the left block is free, it just returns a true or false value. So here the condition is that left and right both blocks are not free. And here we will return a copy block. So this will just copy this stuff. Like it will call my malloc. So let me show you. So copy block. Sorry, yeah. So yeah, this is it. It will just create. It will just call my malloc, and then it will copy the stuff, and it will free the previous block, and it will return the pointer to the space. So that's cool. So the another condition is that both of the blocks are free. Like the block on the left is free and the block on the right is free. Now in that condition, we know that we have to check like is the total size like if all of the three blocks are merged. So let's say the middle one, which is our current block, and the left block and right block. If we are able to merge all three of them, does that satisfy the size? Because if the requested size is greater than all of the like summation of sizes of all of these three blocks, then that means we cannot do any kind of like coalescing to make the summation of the three blocks like valid for the requested size, right? So we would have to call my malloc at the end of the day. So that's what we have to check, but I put that check afterwards. So let me show you what I did. So here, this is just BD. Here, BD means just getting the block data. So current block data, left block data, right block data. This is like so total size. So if we find that the total size is greater than or equal to size, let's also like work on another condition, which is if our total size happens to be less than size, well, in that case, we can't do anything except just call my malloc. So else condition here. So now we know that the total size is greater than size. So even if we are able to merge the current left and right and the two headers and footers, the extra ones, we still can't get the appropriate size, which is the requested size. So we have to call mamalek. So let me just use the copy function here. I guess this is it. Current header, current size, this pointer. Okay, cool, cool. New pointer my malloc. Cool, cool. Yeah, we'll just use copy block. So else, oh, I already did that. Okay, fine. That's fine. Let's keep it over here. So let's go inside this condition where the total size is indeed greater than size. So now we have to first check. We yeah, as you know, we can't just you know, we can do that. That like we can merge all three of them and copy, but then we will be wasting copy, right? Copyright strike, you know. Okay. 4 minutes, 5 minutes in. Nobody's watching this. But if you're watching this, thanks for watching this video, bro. Like most of my viewers like leave at what was it? At 30 seconds or 1 minutes in because it's like it's I make really long videos. I know it's not optimal and all, but if you're watching this 5 minutes 20 seconds in, thanks for watching this, bro. Uh, yeah, okay. Uh, let's go ahead. Okay, so I hope I'm not too loud. Okay, so where was I? Yeah, total size. Yeah. So this is the condition where the total size, where we merge all three of them, is greater than size. So that means we can do some jiu-jitsu, you know. Uh, so another thing in my mind is that let me show you on whiteboard what I mean. So I do have whiteboard and a marker beside me to like show you what I'm thinking. Let me just clean some of it. Okay, yeah, cool. So take a look at this. Let me do this. Cool. Wait. Oh, I messed up. Wait, what? Yep, nice. Sorry for wasting your time. So let's say this is our allocated block. This is allocated, right? And this is of 100 bytes. What if we want to increase it to 200 bytes? Well, my new requested size is supposed to be 200 bytes. Well, that's cool. Wait, let me do better. So the new request comes in. This process asks that, bro, I want my current block size is 100. I don't want it. I want a new block which should be of size 200. Well, what can we do? The first step is that we can merge all three of them. So that will be 100 plus 200. Let's say 400 plus two headers and footers, but let's ignore that for now. But the new size will be 400. And then we can just remove the 200, right? Another thing, well, I don't think we should make this that much complex, right? I'm making this too complex by doing all the left free and right free. Yeah, I think I'm making this too complex. I think just do it simple. Like, so what I had in my mind is that, let's say if the process is asking for 200 and we have both of the blocks free, we don't merge all three of them. We first check that the current block is 100, the right block is 200, the merged block will be of 300. If we allocate this merged block 300, then we will definitely split it. We won't be giving it 300 and extra 100 bytes. That will be a bad case of internal fragmentation. So we will just allocate it a size of 200, which it wants, and then we will split the block of the remaining 100. In this case, it's better, but we should always allocate, like we should always merge the bigger block because, what if this was 108? If this was 108, then this will be a total block size of 200, and then we will create a block of 200, which is the requested one, and a block of 8 bytes. That is this is what is called external fragmentation. This is external fragmentation. We should make it so that the block which is split is like a bigger one. As like if it's bigger, it is more likely for it to be allocated to some other process, so I was thinking of this logic, but now that I think of it, I think we should just like how bad is mem copy? I think the only way where I don't have to copy stuff is that when I merge the current block and the right block, right? That is the only case. But the other cases are current, left plus current plus right. Yep, I think that outweighs. So let's just merge all three of them without any thought. So let's go ahead. I think I've cleared my mind. So yeah, I wrote this in sleep, so I don't remember most of this stuff. So how about we write some better code now? So total size is greater than or equal to size. Then we will let's construct it. So total size, current size, left size, right size. Yeah. So total header. How about we get to that? So header block pointer total header is equal to header block pointer. We don't have to, oh, we do have to cast it. Uh, what should we cast it into? Well, it is technically only should I do this right header? Sorry, left header. I know this is direct. I could have directly used left header, right? Left header, right footer. Cool, cool, cool. So left header and then footer block pointer total footer is equal to right footer. And then I will check that what was the function that takes in difference? In difference. Where was it? Where was it? Where was it? Uh, yep, this is one. So split block function, yeah. The split block function, what it does is that we give it a current block, we give it what our allocated size is supposed to be, and then we give it the difference. Yep, cool, cool, cool. So let's do that. Let's use a copy block function. Where were we? We were over here. Yeah. So we give it a block. So void pointer total space, you can say, is equal to uh, I forgot what the function name was again. I'm so sorry. Size t difference, right? Yep, cool. Split block, yeah, yeah, yeah. So split block takes in the total header. It takes in what our allocated size is supposed to be. We should calculate this difference over here. So, what was it? What was it? What should we call it? Size t difference, right? Yeah. Size t difference is equal to total size. What was it? Total size minus total size minus what our size is supposed to be, so size. And here we will check, that if difference is greater than or equal to header plus footer. So in that case, we'll split the block because at least header and footer will be remaining. And we will call uh, total header is given, and then we have to give what our size is supposed to be, and then the difference, which is difference. Cool. And then we get a split block. So we'll just return total as over here. Cool. We don't need all this rubbish. Yeah, we don't need all this rubbish. Sorry, total as, and there will be another condition where the difference is greater than zero, but it's not header and footer, you know. But in that case, does split block handle the, split block function? Does it handle Yeah, it handles values and next and previous values. Yeah, yeah, yeah. Cool, 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 cool. Boom, 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 boom. Yep, cool. So we were over here. Oh, I was in the correct position. Okay. So split block is cool. This is done. Boom, boom. What we do? Yeah. We can just give it the left and right directly, and we can return it. Hmm. 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 Okay. 15 minutes in. No one's going to watch this. So else if difference is greater than or equal to zero. So if the difference is greater than or equal to zero, which means like header and footer. So the difference is at least header and footer, so that the block can be split. But if it's greater than zero, but it's not at least header and footer. Let's say it's not 32 bytes, it's 24 bytes or 16 bytes or 8 bytes or whatever. But in that condition, we cannot directly split it, because the remaining block won't have sufficient like the minimum bytes that a block need is that a free block needs is header plus footer, right? It's fine if the space is zero, but it needs at least 32 bytes. But if it's still greater than or equal to zero, we can construct the block, but we can directly give it to the process instead of splitting the block. So here, that's what we will do. We will we will change the values over here. So what should I write? Yeah, left block. Yeah. So what was it? Yeah, header block. I do need to create. I should move this above. Wait. Yeah, let's keep it. So yeah, let's remove this. Total header should be left row. Yeah, left header. So this will be left header size is equal to total size or one, and oh sorry, and right footer size is equal to total size or one, and to get the space of the total space, so void pointer total space is equal to uh, void pointer left header plus move it by header forward, right? Yeah, cool. And then we'll return this total space. Cool. Why am I saying cool again and again? I'm not sure. Sorry. So this is fine. So if difference is at least header and footer, then we will split the block. If it's not, then we directly say bro. Left header size is total size or one. Split block also does that, I guess. Split block, yeah. See, or one. So yeah, I guess it's done. So we can just call both free function. So it's not difference is smaller, then we do this. Cool. So we can give the function both free. Return both free. I shouldn't be directly returning function values, right? Because they can be null. Yeah, I'll handle that afterwards. So both free. Let's just get it running. I will add the like exception handling afterwards. It takes a pointer and the size. Yeah, yeah, cool, cool, cool. It takes the current pointer and the align size that we want. Cool. So we have two conditions covered, where the left and right both are not free and both are free. Now we have to cover where the left block is free. It's the same thing, not much difference. So what can I do? Yeah, left free, left free, merge, left merge, right merge. Oh, I can use coalescing functions. Why didn't I use the coalescing function? I have these functions already, bro. These functions do this. It helps to skip the block. Yeah, we did not cover this. Oh boy, it would have been bad. Total new size, left header size, right header size, new block, boom. Ah, it does the same thing. Bro. But it does not free up the space, right? Yeah, we'll do the freeing. We can do the freeing. So what coalescing R does is that we pointer, change the values, and then return a pointer to that. Coalescing R and L. It is coalescing two free blocks. Here we are doing the same thing. We get a pointer to it. Ah, okay. So they just merge two free blocks, create a bigger free block, but they do not copy the stuff. So what if we call coalescing RL and then we get a bigger free block and then we try to change then we do the split block and the mem copy. Yeah, let's do that instead. So yeah, big free block is equal to coalescing RL. What does it take? That takes free pointer and pointer. It takes address of free pointer and it also takes the current pointer, which is yeah, okay, this is a space pointer. Yeah, yeah, cool, cool, cool. So this is the space pointer, so it's fine. So bigger free block, we get that. Our pointer starts from somewhere. Let's copy the stuff first. So to get the free pointer, now we will copy the bigger free block is a space one, right? Coalescing RL is the start of the block. Okay, okay, okay. It's the start of the block. So void pointer big free space is equal to void pointer char pointer big free block plus header. Cool. And then we copy. So mem copy. What is the latency of mem copy? Is mem copy an expensive operation? What is the cost of using the mem copy related to other functions in terms of performance? For example, I'm writing a sequence of numbers to a static buffer. I concentrate on the frame within the buffer in order to keep the frame once I get the end of the buffer. I might mem copy all of it beginning or I can implement an algorithm to amortize the computation. Memcopy is generally optimized to maximize memory bandwidth of large copies. Of course, it's not as fast as avoiding a copy completely. And for short copies of fixed size, yeah, okay. Wait, it's highly portable and most compilers go to great lengths to make it fast, whether that's using simple instructions or limiting in memory. Okay, good. Sure, let's use memcopy. So we will copy it to big free space. We want to copy from the pointer and the stuff that we want to copy is of size at least block size. Cool. So now we still haven't split the block. So let's split the block now. So we have to still call split the block. We get a pointer to it. So pointer, new space is equal to split block. Sorry, yeah, 30 minutes in. That's cool. So split block is actually returning allocated space. Yeah. So so split oh I forgot. Split block takes the block that we want to keep, so which is left header. Hmm. And then how much size do we want to keep? So the size that we want to keep is of size. And then what is the difference? Hmm. We do have difference calculated above, right? Block size minus align size. Well, that's not the difference that we want. Yeah, this is just bad code. Let's remove this altogether. Difference is like the difference, the final difference of how much block that needs to be kept. So, split difference, what should we call it? The merged size is so big three block. So header block big three header is equal to header block pointer big three block. uh, Split difference is big three size minus the size that we want, and then we will pass this stuff as split difference. Cool. And now we return this space. Yep, this seems correct. This seems correct. Okay, it does not mean that it is correct. This just looks correct. So I think I have to do the same thing for the left and right. So uh, left free. So in case of left free, we'll still do void. Let's call it current RL, current RLS. Mm-hmm. The pointer that we want to copy from and the block size. Cool, 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 cool. Left header. What is a left header? What are you talking about? Exactly. Coalescing RL does not return stuff. This should be current RL. Current RL is the size, the starting of the block. Oh boy. Yeah, block. So useful difference is difference. Yeah, yeah. So this is taken as header. Yeah, yeah, cool, 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 cool. So this is taken as header. This is taken as allocated header, allocated footer is at this, the block that I want. Yep, this is cool. This is perfect. So current L, how about we call that current L? So current L is equal to coalescing L, three pointer, and then void pointer. This is also void pointer. Current L space is actually cat pointer current L plus header. This seems repetitive, right? I have to do the same thing for left and right too. So how about we make a function that does this for us, you know? Yeah, let's do that. The function will be called coalesce copy. Yep. Void pointer coalesce copy. Yeah. So this will take a pointer at the start of the block. This will also need free pointer. So this will take uh, void pointer. Well, not a void pointer, but yeah, it will need a void pointer. The pointer is a space one, right? Yeah, fine. It will take a void pointer. It will take void pointer to pointer free pointer because we are going to be passing address to it because it is my real function. Yeah, sure. And then we will also need to pass size. Yep, to pass the size and the current block size. Yeah, size d size, and I should put this block size. I guess that is all we need. Yep, that is all we need. So now we will do the operation. So yeah, so what this function does is that it gets a pointer. It will try to find what is the so block is equal to header block pointer. Oops, messed up. Header block pointer, cat pointer. That is not true, right? Pointer is the space one. And when we are passing this to the coalescing RL function, then the space is not considered. Let me check. Is the space considered? Yes, it's considered. Okay, sure. So correlation RL considers the space. Yeah, okay, cool. There will be. Yeah, over here. So this is space to get the header block of the block minus header. So here we get the block. We have to coalesce and copy. I forgot. My brain isn't working. What was I going to do? Yeah, use this. Yeah. So to get the space, I'm already at that space. So no need of that. Oh, my bad. My bad. I'm so sorry. I'll be passing this. Let's copy the entire stuff. So yank, paste, equal to boom, delete. So the current block will be coalescing stuff. So wait, we will be handling the coalescing, right? Yeah, we will be handling the coalescing. We will do the coalescing R and L and whatever whatnot. And we will just give the pointer of the space. No, of the entire block. Yep, cool, cool. So we won't be doing this at all. The pointer that we get over here is of the total block. Merged pointer. Yeah, let's call it that. So merged pointer space. Merged space is at merged pointer plus header. So that's fine. And to get the header block, merged header is this. Merged header is this. Yup. And then merged space is this, which we want only for copy. Split difference is current merged header size. Merged header size minus size. And merged space is the start, which is the pointer plus header. So that's cool. Whew. We copy from split block starting from merged header. Yeah, merged header split with size and the split difference. Block size is wait, was block size important at all? Block size was used for what was it used for? Yeah, the copy thing. How much do we want to copy? Yeah, okay. We do need a difference we get from over here. So we give it a pointer, which is the merged pointer. So this is a pointer which is pointing at oh, pointing at the new block. If we move it by header forward, we copy everything from copy from. Hmm. I don't know what to say. I've done a lot of stuff over here, and I think something is going to mess up because I have this feeling that I have messed up with something, but I don't know what. So corners copy should return us the space, right? Yeah, it should return us a space. No space is equal to corners copy the most pointer. So we still have to do this. So current RL coalescing most pointer is supposed to be the start of the block, which is what coalescing returns. So we will pass it over here. Boom. Copy from. So this is the pointer. So dt boom pointer. This is free pointer. So dt boom 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 boom. This is the block size. So this is cool. And this is the size. Coalesce copy. So what it does, it takes the current most pointer, which it will be at, and then it takes a pointer. It takes a free pointer just in case the split block is added to whatnot over here. A split block should also take a pointer, free pointer, right? How is it splitting? Okay, so we don't need the address of free pointer. Okay, OLS copy. We don't need a free pointer. Duh. Sorry. So we don't need this at all. Cool. And now we successfully don't need this. And then we can just return new s. Hopefully. The same for RL, we can do the stuff. So void pointer current L is equal to coalescing L, only the L. So free pointer, pointer. I have to clean a lot of stuff. That's what I realize now. So void pointer, new space is equal to coalesce, copy what we want to copy, the pointer to it, block size and size. Cool. I know a lot of repetitive code, but I'll optimize it later. Okay, so the new pointer, I should make a new space pointer, I guess. Okay, so I can make a new space pointer instead. Copy block. Yeah, let's do it. So void pointer new space is equal to null, and here we just set new as equal to this stuff, and here we just return the stuff. Cool. Does this work? Definitely not, but you know, we should try. Why does that not work? Expected expression block, header block. Oh yeah, yeah, yeah. Okay, okay, okay. What's the line number? 533. Then we have 535, which is block, the block, redefinition of block, and 535. Okay, redefinition of block. If this is not needed, we don't need it. Yeah, okay, the redefinition one. Sure. Now we will see the real errors, lot of errors. Oh, it worked. Damn. Okay. Okay. Let's see. Yep, it's not working. Okay, so it's not working. Why is it not working? Let's debug, or should we leave it for the next video? It's already 53 minutes in. Let's debug in the next video. This video can be about, I completed the, wait, how many changes did we do? Git diff, wait, clean, git diff. Yeah, this is fine. And then we did this, a lot of additions, which is both free. Yeah, we don't need both free, by the way. We don't need both free. Both free is just, no one's using both free right now. Yeah, we don't need this. Trash. Yeah, nothing is going to change. Yeah, sure. Let's take a look. So make debug equal to 1, db and driver run dash g. Yeah, okay. So we messed up over here. Why though? So split header size, split footer is at this, bad access. is equal to, we cannot set the size value for this. Split footer is something rubbish. This is trash. Okay, if we go up, then frame variable. Sorry. So the difference that we get is trash, definitely. Yep, okay. We are messing up somewhere, but we'll find out. No problem. I I think it's mostly because of plus minus, the ORs and uh, ands that we're doing the LSB1. But I guess yeah, let's end the video. I will uh, fix the errors. Like I'll do the debugging in the next video. For that time being, how about we accept this and yeah, let's say on a copy boot free function like completely. Yeah, we don't need repetitive functions in our block. So this is copy block by free. How many times is copy block used? Twice? Seriously? Hmm, strange. Hmm. Okay, sure. So what we did was this over here, no block found was removed. The name was changed to copy block. Then we added, sorry, yeah, we removed a lot of things. Oh, the yellow. Yeah, yeah. Let's, sorry. Oh, I messed up. Yeah, it was a small change, nothing much. Just adding functionality, working. What should be our commit message? I'm thinking about that. Our commit message should be working on realloc, right? What does our git log look like? Making code more ready, yeah. Git commit, working on realloc, and git push, git branch, and git push. Yeah, thanks for watching this video. I'm Al and I'm an engineer for fun. How about we wait for yeah, okay, now let's do it. I'm Aditya Pacharni and I'm an engineer for fun. Bye.